Okay, let's go ahead and get started. First of all, I want to say thank you to everyone who came out this afternoon. I know being the last session of the day, on the first day, who knows going to be here, but I appreciate you attending and plan to give you some stuff here on threat modeling. How many of you have done some threat modeling in the past? Okay, a few of you. Excellent, excellent. How many of you, this is the first time you ever heard about threat modeling? It's okay. Second time's okay as well. All right, excellent. All right, well, again, welcome. So a little bit about me. My name is Robert Hurlbut, and I'm coming in from Connecticut, where I live and work. And in particular, I'm right now working as a threat modeling architect for a large financial institution. But for a number of years, I was a consultant. In fact, really the last 15 years as an independent consultant. And for 30 years, I've been working as a developer, software architect, and then also a number of years focusing on application security. In that time that I've been focusing on application security, I've also been focusing quite a bit on threat modeling. And especially in the last number of years, I've been working with teams in various places and various companies and situations, financial, healthcare, commercial products, open source products, and other kinds of things to try to help them understand about threat modeling, but also help them threat model their particular applications and to think through security issues in a more direct way. And so those are some of the things that we're going to be talking about today. Some of my experiences, share some of those with you, as well as what is threat modeling, how do you do this, and hopefully as you leave here you'll maybe gain some things, as well as understand maybe some other ways or some ways to apply threat modeling in your own particular situation. Some other things, in particular, I'm a co-host with Chris Romeo of the Application Security Podcast. How many of you may have heard that? Okay, well, I welcome you to listen to it. It's out there. If you want to look it up on Twitter, it's AppSec Podcast. Go take a look. We've got 2 seasons out there, and we're starting our 3rd. And basically, just a lot of review of application security topics, as well as great interviews with people in the industry. So we're going to be continuing to do that this year as well. So welcome you to check that out. Okay, so today for our agenda, I was trying to figure out the best way to put this together, and I thought I've never really had an outline. I thought, well, why don't I put one out? And it's very, very simple. Why, what, when, who, and how. So let's talk about the why. Why do we even care about this stuff? How many of you are developers here? Okay, the majority of you. Okay, how about project managers maybe? Okay, a few. How about a QA or a testing person? Okay. How about anything else that I missed? Maybe security. Are you a security person? Okay, excellent. Okay, welcome. All right, well, in terms of software design, when you're building out applications, I'm sure, especially those of you who have been doing development for a while, you're probably pretty familiar with this, or architecture in general, is determining requirements, try to understand what it is you're trying to build, what are the functional and non-functional requirements that are a part of that system, and then you try to implement those requirements through features, right? You think about, well, I know that it's a web application, so I need something to be supported in a browser. I need to write with some kind of framework, perhaps. It's a mobile application, so therefore I know I need certain tools in place to be able to implement these things in a browser, or sorry, in a mobile application and interact with a server, perhaps, cloud, and so on and so on. So different features that you have to think about. Ultimately, what you're trying to do is build software that people will use, right? How many of you are building software that you don't want anybody to use? Okay, I'm glad no one held up their hand. Everybody, hopefully, is building something that somebody is using, or at least that's the intent. Right? You want them to use it. You want them to have good reviews about it, and get some feedback and that sort of thing, right? Well, in terms of secure software design, you're doing something very similar. You're determining the secure requirements. Do we need any kind of logging into the system? Do we need any kind of access control? Do we need role-based access or any other kinds of access control? Do we need those kinds of things in our application? And of course, then you implement those things through features. I have a login page. I have various ways to track my roles in the application and things like that. And guess what? We still want to build software that people will use. But we also want to make sure that, as people use it and they don't come back to us and say, hey, I can't use it because it's too locked down. You might get some of those kinds of things that happen, and so you have to work with them and trade-offs and things like that. But one of the interesting things that you're also trying to do is figure out misuse and anticipate misuse. So it's not just building the software that people will use, but it's also thinking about how will people misuse potentially this application to do something different than it was expected. How can they, for example, bypass my login form to get in to the rest of the application or to the website, for example, and do other things? How can they transfer money from one account to another that they shouldn't have access to be able to do? Those kinds of things. And so the big question there is, how and why do we care? Well, let's talk about why. There's some good examples out there about some reasons why in terms of breakdown in secure software design. How many are familiar with this one, the Jeep Cherokee hack? Yeah, a few years ago now. In particular, this one was where a couple guys here, a couple researchers here, Charlie Miller and Chris Valisak, were looking at Jeep Cherokee, and they've been doing this for a year or two, and taking a look at the entertainment center, or system rather, in the Jeep Cherokee in this particular case. And it turned out there was a vulnerability in the system. All these Jeep Cherokees had the ability to get internet access so that, from the car you could go out and play your Netflix or whatever, connect to the internet and do something, right? The interesting thing about it is that, of course, all of those cars also had an IP endpoint. So they're on the internet. And because of the fact they're on the internet and because of a vulnerability in the car itself, in the entertainment system, somebody could get through that IP endpoint into the car and then take over the car and take control of it. And so that was some of the things that they did in terms of showing this. And in fact, there's a picture here on the right-hand side where remotely they were controlling this Jeep Cherokee and they were able to force the car into a ditch. And the person who was driving it couldn't stop it. He tried to put the brake on and all that stuff, couldn't do it. They were able to remotely control the car. Now that's a breakdown in secure software design, because whoever thought that it's okay to let anybody from the outside be able to get in and take control of the car? That wasn't really well thought of or thought through. Another one is something that happened recently, last August, was this information about pacemakers and a recall. And it turned out it was an unauthenticated access issue. The problem was that these particular pacemakers, and they were saying there were something like 500,000 pacemakers out there with this problem, is that it turned out that if somebody was close enough, 20 yards, 50 yards, they would be able to connect to this pacemaker inside a person and be able to take control of it. There was no access control. There was nothing to prevent that from happening because, guess what? Nobody would ever do that, right? And so now we've got a potential flaw, and so again, a potential death problem here, because obviously somebody who has it, has to go through some way to fix it. And in fact, the fix was, it turns out, you go into a doctor's office, you sit there, and they say, okay, we're going to apply a patch. Hang on, it's going to reboot. Okay, come on. It's funny, but not so funny, right? Because these kinds of things, when you're thinking about building secure software, sometimes we think, well, just the simple things, but it can also deal with life and death, as I talked about with the car, and now I'm talking about with the pacemaker. Now, there are some other examples here of secure software design breakdowns. How many of you heard about the connected light bulbs that have unencrypted passwords? Yeah. How about the hijacked toasters? You heard about those? And the hijacked baby monitors. I mean, those are out there. So these are other devices and other things that have some kind of software flaw in them in terms of the design of that particular software that's running those things. And as a result of decisions that were made, they are now vulnerable and potentially open to be attacked and compromised, hijacked, and so on. So we've seen these things. We've seen these examples and lots of examples out there. But what are the common themes? Well, I think one of them is that they're missing this what could go wrong question, from what I can tell. What could go wrong here, and are we thinking about all the possibilities? And the other thing, I think, pretty obvious with the authenticated, a lack of access control in the pacemaker and so on, is they're missing some security controls of some sort. Something's missing. And then finally, what are the risks and trade-offs? Now, maybe they did think about this. Maybe they knew, for example, with the Jeep Cherokee that this was a possibility, but we don't ever think it will happen. But it's still a risk and trade-off. Security is always going to be a risk and trade-off. Whenever you determine there's a need, then you've got to determine what's next. Now that I know that there's an issue, now that I know there's a threat, what do I do with that information? Do I fix it? Do I not fix it? And so on. And I know a lot of companies right now are dealing with the most latest thing. You've heard of Meltdown and Spectre. There's some big things going on right now in the security industry, certainly, and with the industry in general and companies. Trying to think about, okay, now I know this, what do I do with it? Well, this is where I think threat modeling can help to determine these kinds of things. What could go wrong? What security controls are missing? And then what are the risks and trade-offs? So let's talk about the what. What is threat modeling? Well, before I get into that just a moment, you're probably, at least I hope so, already doing these things. How about pen testing of some sort? Okay, vulnerability assessments, okay? DAS, SAS tools, that sort of thing, source control review and so forth, automated tools. Okay, great, I hope so. But if you're not doing threat modeling, you're missing a lot. So all those tools are great, but guess what? Majority of those tools work on code that's already done or a product that's already done. It's already shipped or it's ready to ship, and then you run those kinds of tools against them to find out what's wrong. Of course, source control tools will check things as you go along as well, but at the same time, it's not going to always find those decisions that were made one way or the other. For example, it's not going to find, did you encrypt the password, or rather hash the password with a good secure hashing algorithm? It's just not going to tell you that necessarily. So threat modeling helps you think about these things strategically, about your design. It's a way of thinking, essentially. So it's not an automated tool. There are some tools out there that help you build threat models, but the reality is this is another kind of tool in your toolbox that should be there, but it's a different kind of tool than the automated tools, where this one is one that helps you think about this stuff, okay? And so essentially it's that process of understanding your system and the threats, and as I like to think of it, and some of my friends do as well, that we think of it as critical thinking about security. It's being critical about your product, about your application, about your design, about your system. It's not just assuming that everything is okay. It's not just saying, hey, because we got a great pen test, we're good. It's really thinking through the design, the architecture, and the system to determine, are we really doing everything that we should be doing, and decisions that we made are good. So typically a threat model includes these things: an understanding of the system. So what did you build? What are you building? The threats, the mitigations, so the controls that you want to put in place. And then finally, as I mentioned about risk, what are we going to do with that information? What does it mean to us, and where do we go from here? There's a whole vocabulary on threat modeling, and this link will get you to this particular image, but you can see how threats are related to the attacks, and how the vectors are related to other things, and so on, and probability and risk. And so there's a lot of things going on with threat modeling, but essentially the biggest thing here is thinking about the threats, what could go wrong, thinking about the kinds of controls that I need to put in place to deal with those threats, and then the risk or the probability of those risks or that threat being realized happening. That's the main thing that we're going to be talking about today. So when do you do this? Well, ideally you do this early on. So if you're following any kind of SDLC, secure software development lifecycle, perhaps, or software development lifecycle, ideally you want to put this into the design phase. So very early on, think about what could go wrong on paper before you think about what could go wrong after the fact when the thing is running, as much as possible. That's the key. And that threat modeling, what it's going to do when you're actively engaged in threat modeling in the design phase, it's going to uncover the new requirements. It's going to help you think about what's missing and what should be there that's not there already. If you're following an agile methodology, I like to say that threat modeling could fit in a lot of different places. For example, whenever you're thinking about sprint planning, that's a great place to think about what could go wrong here. What's the maybe an attacker story, not just the user story, but what's an attacker story? What's the opposite of thing the thing that we want. You know, the user story says, as a user, I want to be able to do something. Well, as an attacker, what could I do instead? And work your way backwards and figure out the controls that you need to put in place to mitigate those things. If you're following DevOps or you have a DevOps culture in place, a lot of things are moving very fast. And I've heard people say, well, I can't do threat modeling because I've got DevOps going on. We never stop. We never, you know, everything is always moving very fast. What I like to say is that somewhere in there you did some kind of design, somewhere, hopefully. Also, you can apply some of the things that I mentioned before. Anytime that you're doing any kind of code write-up or architecture, you still need to be thinking about these things. You still need to have that critical eye about the security implications of what I'm building. All right, so who does this stuff? Well, hopefully, ideally, your security team knows about threat modeling. Okay? If not, then something's wrong, because this is definitely probably the foundation of security, to think about what could go wrong, what could happen here, and how do I deal with it. Other teams should be involved in threat modeling. I don't think it's one person's job. If it's just a security team and they're the only ones doing threat modeling, they're going to be missing a lot. It's the other people also that needs to be involved that know about the system. You know, your developers know, for example, what algorithm they used for the passwords in the database. Your QA knows a few things about how it's being tested, and the architects and so on. So it's not one person's job. It's many people that should know this. Now, who else should know about it? Everybody else. I think everybody should be exposed to this. You can do threat modeling not just for applications, software applications, but you can also do threat modeling for an organization. You know, what happens if somebody comes through the door and, you know, one of those things where you come in and somebody follows them without swiping the card. You know, what happens then? There's physical security issues there. That's also a way of thinking about threat modeling. Very key, though, when you're going to be doing threat modeling is sometimes, especially if you're doing an evaluation of a system that's already existing. And believe me, when I'm called to do threat modeling, the majority of the time I'm called is not at the beginning. It's already been done, just what it is. If you're already threat modeling, or you're threat modeling an existing system, here are some really key things. Be honest. You know, yeah, we screwed up. We did something wrong. But that's okay. Be honest about it. Leave ego at the door. And don't blame. The purpose of this, whenever you're doing any kind of threat model or trying to think about a system, the security of a system, is to discover what's wrong. So be open to it. Be okay with it. Because otherwise, if you just say, I'm not going to tell anybody, I'm just going to hide it, and maybe they'll never figure it out, nobody wins. Guess what? Somebody will finally figure it out from the outside. So that's the last person you want. The first person you want to know is us, you know, the teams that are working on this stuff. Okay, so how? Now we're going to talk about the how. In terms of how, there are many different ways to do threat modeling. In particular, I'm focusing today, because this is secure application design, I'm going to be talking about the application method of threat modeling. You may have also heard of attacker threat modeling, where you think about the attackers and what is it they want to do. Is it nation states? Is it the script kiddies? You may think about asset threat modeling, where all I'm going to do is focus on the things I'm protecting. It's the database, it's the credit cards, it's this, it's that, and work my way out. And that's okay too, but my primary way of focus is on software, because I'm a software person. And so I focus on how applications work together. And I find as I do that, I uncover the assets. I find out what things need to be protected and where and when and why. And I also sometimes might then revisit and say, well, who's interested in doing this? Who would ever break into the system? And then that might change my threat model a little bit too. But I wanted to give you that kind of preface, because what I'm going to show you the rest of the time here is what's called the software method of threat modeling, or application threat modeling. So the process itself. I have 4 things I want to go through. Draw your picture or understand the system and the data flows. We'll talk about that. Identifying the threats through answers to questions. So ask the right questions if you can. Determine the mitigations and risks. And then finally, a follow-through. And if you're familiar with a book that came out a couple years ago by Adam Shostak on threat modeling, This is very similar to his particular method of doing threat modeling. He talks about what are you building, so that's similar to number one. What could go wrong, identifying the threats. What are you going to do about it now? That's the mitigations and risks. And then, did we do a good job? And that's the follow-through. So it's just kind of a variation of what he had provided in his book. So the first thing, draw your picture. Do you know what that is? Anybody? No. No, that is not your threat model. A couple of boundaries, but what kind of application is it? You have an idea? Yeah, an interior, probably a web app. I would say it's a web application. Okay, great. What do you know about the security of the system from this diagram? Excellent. How many of you have ever heard, is it secure? Yes, it's got HTTPS. Okay, is that enough? No. So I know it's HTTPS. Okay. My point is, if you've been given this, has anybody ever been given a diagram like this? If that's what you're working on, that is not enough to figure out the security of your system. It's just not enough. All I know is, yeah, a couple things here, HTTPS, and I know that I've got some things running in the web server, and I've probably got some kind of data going to the database, secure or not, encrypted or not, sensitive or not, I don't know. But this is not enough. My point is, this is not enough. If you're just given this as a diagram, you need to go a little further. You need to ask some more questions. One way to do that is to use, at least in terms of threat modeling, as many people have done it, is to use what's called a data flow diagram. And a data flow diagram really helps you think about how does data flow through the system. Why do we care? Well, it turns out that one of the most sensitive areas of your application typically is the data. You know, whether that data is at rest or that data is moving around or that data is being held by something, it's important, or changing and so on. And so what we like to use in terms of threat models is this thing called data flow diagram. Now the reality is you could also use other things to figure this out. You can use decision trees, you can use various ways of how things are moving back and forth and kind of a flowchart type of thing. But this one is really important and helpful, not to say, okay, this is first thing, second thing, third thing, but how does data flow throughout the system in order to see where we're most vulnerable in the system? How are we protecting that data? And so there's a few things here. The external entity, so a user, for example, a process. What are some things that the system does? Multi-process, maybe there's a representation of something that multiple things are going on underneath, not just one. A data store with two lines, a data flow with an arrow. And then finally there's this thing called a trust boundary or an attack surface. It's really trying to understand kind of a boundary around various parts of your system, either virtual or real, that define some things in this system are more protected or more sensitive than maybe somewhere else. And in order to get into this, I need more trust. You know, maybe I need to have a login here. Maybe I need to have some kind of access control. And so that's important to us when we're evaluating a threat model or a system, is to try to understand where the areas are we most vulnerable again. So let's take a look at, again, what we talked about is trying to think about the system by breaking it down into the logical component parts of the system, as well as understand the data flow, as I mentioned. So the simplest way we can do this, just at the beginning, is just to think about a couple of users here and a server, and maybe a request and response, and maybe in this case saving some logging data or retrieving logging data and setting some admin settings. And so from this, what we call maybe a level 0, I know that there are a couple of users involved. I know there's some data moving around, but it's really not quite enough yet. It's you know, again, a high-level view. And ideally, you want to go a little further. And in this case, I've broken it out into the web application and some services that might be involved. And so then I want to go ahead and enumerate some of those things. And so then I'll indicate that, okay, here's a box that represents a user. Here's a process, in this case maybe a web application. And maybe even further, maybe I want to say that this web application saves data in some way or retrieves data another way, and so on. Maybe a service does something and a couple other things. But again, this is maybe a level 1 data flow diagram. So then I want to draw some trust boundaries where I determine maybe trust changes as you go through the system. And so I'll go through and do that. Next thing is I want to, once I've done this, and maybe a few things in the system that I've done this to, I want to also label some of those things. So determine, what are our entities, what are our processes, the data stores, what do I want to save here, or what's being saved. So for example, my data stores, I have some data files, configuration files. I also have some credentials, maybe a database or something like that. And then identify some data flows. So all we're doing here initially is, this is not your threat model, by the way. This is not your threat model. A data flow diagram is not your threat model. A data flow diagram is just a way of thinking about your architecture, thinking about your system, and getting started to understand how does this thing interact with that thing? What kind of data is being sent? And then we're going to get into how do you ask questions about these things. So again, the first part of this is really just the diagram, understanding your system and the data flows. The next part is really identifying the threats, which interestingly enough is the most important part. It's threat modeling after all, but it's also can be the most difficult because there are many ways to do this, but we may not know all the kinds of potential threats there are in the system. And there are some tools to help you. But the key thing is determine what way works best for your team. I'm going to show you a few ways there are. One is to use attack trees, which are essentially a way of thinking about a user or thinking about a process and thinking about a goal. Let's say, for example, and Bruce Schneer, he has a slide deck on this. If you're interested, take a look at it. He gives an example of, let's say I want to be opening or break into a safe in a bank. How would I do that? And here's the goal, the safe, the asset. Here's you trying to figure out how can I break into the safe. And you come up with essentially a decision tree. Okay, well, let's say I can go take the manager out for drinks one night and see if he might happen to give me the combination of the safe. Maybe that'll work, maybe it won't. Another is that you could be a part of the company that put the safe in place. Now you have to go way back and do that, but if you're one of the people that put the safe in place, you can maybe do something a little different when you put it in, so you know there's a back door or something else like that on it. And other ways to think about how do I get from point A to point B and the different decisions that I need to make and the risks of each or the probability of each or the likelihood of each and so on. So that's one way to think about a threat model or to determine threats. Another is there's a lot of threat libraries out there that can help you think about this stuff. CAPAC is one. The OWASP Top 10 gives you at least an initial list of some things that could go wrong. There are some checklists. Anybody familiar with the ASVS from OWASP? Okay, excellent. If you haven't looked at it, it's a really interesting list of things about, I think it's 19 different categories of software development, primarily web, but it can apply to other applications as well, in terms of asking questions about your system. Are you implementing some kind of access control? What are you doing with your passwords? How are you storing them? And so on. And you can turn that list then into what's the threat? What's the possibility? What could happen if I don't do this? And what do I need to do to protect against it? You can also do use cases and misuse cases. This goes back to what I was talking about, the agile methodology. So you think about use cases and the misuse cases. Misuse cases really help you with this. No one would ever do that. Ask that question. It also helps you who would ever do that. I've had that happen before when I'm with a team and we talk about some things and I'll ask a question. They say, no one would ever do that. No one would ever click on that other page and do something different. The most familiar to most people that have done any kind of threat modeling is probably the STRIDE framework. Have some of you heard of STRIDE? Yes. Okay. Well, STRIDE essentially is 6 categories, or rather it's 6 letters, if you will, that represent types of potential threats. And it's really just a mnemonic. It's just a way of helping you think about some common ways that a threat could happen. So for example, spoofing, being somebody else, pretending to be somebody else, tampering, changing data, repudiation. Essentially, can you really prove that I did something? Information disclosure, of course, information being exposed. Denial of service is that preventing of a system to be able to do what it needs to do. Elevation of privilege is bypassing everything else, basically access control. I can do things as an admin, for example, when I'm really just a regular user. The property we want for Stride, really what it's trying to do is help us think about the things that we really should have in place. So spoofing, the opposite of that thing is authentication. So if I can spoof, how do I fix it? Well, I need to have proper authentication in place. I need to have logging in and so on. For tampering, I need some kind of data integrity, some data checks and verification that I'm doing the proper things. Repudiation, non-repudiation, which basically just means auditing or accountability. Logging, for example, is a great way to deal with repudiation issues. Information disclosure, confidentiality. Denial of service, availability. So making sure that your system is available and can handle denial of service issues. And authorization, dealing with elevation of privilege. If you've done some security before, you may recognize some of these things from the CIA of security, so the confidentiality, integrity, and availability, as well as the 2 A's or maybe 3 A's if you consider authentication, authorization, and auditing or accountability. So that's really what we're talking about with Stride. It's just helping people who may not be familiar with security to think about these things. And so when you're looking at, let's say, a connection from a source and a target, a data flow, maybe crossing a boundary, you ask those questions. Okay, is there a spoofing issue here? Could somebody pretend to be something else? Is there a tampering? Maybe somebody could change the data as it moves from one place to another. Is there any logging in place? What kind of logging do we have? Information disclosure, denial of service. Can we, maybe force this to come down from working normally by just simply hitting a lot of times? And then, of course, elevation of privilege, being able to elevate to a higher privilege. So those are kinds of questions that you might ask with Stride. Additionally, what I like to do is not just Stride, but I also like to ask some other functional questions about data validation, configuration management, sensitive data, cryptography. What are you doing about cryptography? Auditing and logging and so on. Who's interested in this? What kind of agents might want to get at this thing? What are the assets, the goals? What kind of methods maybe they're using to get into this? And then, are there any other attack surfaces exposed that we may have missed when we were doing our analysis earlier? And then we also ask about authentication between callers and services, authorization, and so on, and so on. One of the best questions to ask: what keeps you up at night? I find this is an interesting one because when I've asked this with teams, especially when they have a system that's already been built, and I ask that question, it's always interesting to see the reply. Well, there's a button out there on a site that we put in there for testing, and then we hope nobody ever clicks on it because it gives them admin. It was what we used for testing, and nobody hopefully will ever find it, and so on and so on. So that's a good question to ask. Here's an example of identifying threats. The Barnaby 5 example here. Confused deputy problem. How many of you have heard of this issue? Okay, wow. It's a real thing, believe me. Implied trust. What this has having to do with is, and I see this quite often actually in microservices these days. Everybody's going to microservices. Microservices are great. I have no problem with microservices. But one thing that's interesting about microservices is sometimes about security. For example, if you have service A, service B, and service C, and you need some kind of way to manage the calling of B to C because it's a highly privileged operation, but it's not really done. It's just implied that B should only be the one calling C, and there's nothing to protect A calling C. Well, then what you have essentially, potentially, is a confused deputy problem. So what happens is that somebody could call B, anybody could call B to call C, and pass it on. So in this case, B becomes the deputy. I don't know. Whoever calls me, I'll call C. Doesn't matter. I'll never check. And so that's a potential problem that, I see in microservices. And so how do you deal with that is really by capabilities, claims, verifying the access control. Going back to our data flow diagram earlier, let's evaluate a configuration management issue. Where would you think configurations would be held in this particular system? For this web application? It could. But in this particular instance, it's probably the data files up there. In fact, I said it earlier, those are configuration files. So data files such as configuration files. So let's talk about that and try to think about a particular threat that might potentially happen here. So what do we have here? Our system is a web application that uses configuration files. Some security principles to think about is we want to be reluctant to trust and assume secrets are not safe. So questions that we might have is, how does this app use the configuration files? Now, I don't know about you, but how many of you have seen configuration files that have passwords in them? Yeah. And connections to services and other kinds of things and other maybe sensitive data. Yeah, absolutely. Well, okay, should all that stuff be in there? Should it be protected? What's going on here? So the other question along with that is, what validation is applied? So what would happen if somebody changed the data in that configuration file and the service or the web application or something else read that in and it's wrong and it's different than what should be there? It's unexpected. It's to another database. It's to something else. What is happening? Is there anything that checks that, or is it just an implied trust? So possible controls and mitigation, we're jumping ahead a little bit, is maybe to set permissions on those configuration files. Maybe it turns out that I don't want just everything to be in there, or maybe I want to protect it so that not just anybody could change that. And then validate data input from those files. Maybe there are some things that I need to verify. If I'm connecting to a database and somebody put another database connection in there, another password and so forth, do I know that's the right one? Is there something to verify it? One great way to do that or to test it is to use fuzz testing. Just send in a bunch of data to your application. Send it a bunch of configuration files and see how it reacts to understand how your application is handling those kinds of things. So identifying threats through answers to questions. Many different ways to do that. Finally, once you determine your threats, you also want to determine the mitigations, of course. You want to determine, for example, if you determine that authentication is missing, well, now I need a login control. If authorization is missing, well, I need some kind of access control. I need to figure out those kinds of things. But some of the options I might have in terms of mitigation are leave it as is. So I know there's a problem, but I don't care. I'm just going to leave it. It's all good. Remove it from the product. If I find there's a problem in my application, maybe I need to remove it. I know one of the cars that had a problem with the internet coming in, they just completely removed that feature. They turned it off. That was their way of mitigating it. Whereas Chrysler with the Jeep Cherokee, what they did was they sent out USBs that you can stick into your car. Now, I don't know about you, but getting a USB and just plugging it into something and see what happens, I don't know. But anyway, that was how they dealt with it to get it to you. And okay. But remedy with a technology countermeasure is the other way to deal with this. Put in the right measure, put in the right control. Now, finally, one other option you have is warn the user. Okay. Now, this is what I call pass the buck. We know it's a problem. We're going to tell you it's a problem. It's on you to use it. And you may even see this, or imply it or not, if you go into McDonald's and they have a wide open Wi-Fi and you decide to connect to it and connect to your bank, that's on you, okay? That's a risk. And there's a threat there, obviously. If you're connecting to anything, especially if it's open, over an open Wi-Fi, it's on you, but you're taking the risk. And so that's, there's a threat there, but they warn you, okay, it's open, it's on you. What's the risk associated with that vulnerability? Well, a few ways to determine risk. risk management, there's a fair approach, which is an analytical way of determining risk. A lot of things that you try to determine based on money, based on value. How much does this cost? If it's let's say if it's a $100,000 fix for a $10,000 threat, you say, well, geez, do I really want to take that kind of hit for this kind of thing? So you try to determine those kinds of things through the fair approach. Another is CVSS, which is a way of scoring risk, and then try to determine, based on various factors, which one is more critical than another. Another one, just a kind of more of a subjective way of dealing with this, and some of the tools will do this, is a high, medium, or low. And basically, ways that you might think about that are the standard ways of thinking about risk, ease of exploitation, and business impact. And so ease of exploitation, how easy is it somebody to be able to manipulate this thing, be able to circumvent my controls? The business impact, if they did this, what would happen? Would it affect a lot of users? Will we be put out of business? Those kinds of things that you're going to ask. And so you have this high, medium, low, and you determine where am I. And again, some of it's subjective, but you might determine, what is this? It's a medium risk, for example. In this case, this is a CSRF. Going back to our configuration management example, let's think about what is the risk here. Well, remember what we talked about, the system, we talked about principles, we talked about some controls. Where does it matter in terms of risk? Well, I think that if you own it, it may not be as risky. If you're the one managing it, if you're the one who's taking care of it, nobody controls it except you or touches it except you, then your risk may be lower, right? But if it's somewhere else, for example, if it's out on the cloud, I know Azure and AWS, they both offer now certain ways to store passwords and to keep them separate from your configuration files and things like that. So you may think about that in terms of risk. It's somewhere else. I don't have it. It's not mine. It's mine, but it's out there. Somebody else is managing it. Somebody else could touch it. So maybe the risk is higher. And so then you apply the threat model to think, okay, in this case, I'm more concerned about the configuration files than maybe when I have it on-prem. And so this essentially is our threat model in this particular case, where we think about our system, we think about the possible threats, we think about the particular mitigations, controls, and tests, and so forth, and we think about the risk. And all of this together, then we determine, what do we do next? Do we change the configuration file? Do we push our password somewhere else instead of the configuration file? Things like that. So again, mitigations and risk identified to deal with the threats. The follow-through is really just coming back to, okay, now we've done this, now we've gone through this exercise, we've figured out a few things, what do we do next? Well, document what you found and file bugs or new requirements. I mean, that's the purpose and the point of threat modeling. It's to help you find those requirements. It's to help you find potential bugs or issues within your system so that you can address them and then verify they're fixed. Now, I want to ask you, when do you think you're done with threat modeling? Yeah. It's something that you want to continue to do or to revisit or to think about. And with that in mind, I mean, it's something that, the first time when you do this, especially if you've never done it with a system and you need to evaluate a few things, it may take some time to look at the system if you've never evaluated it. But over time, and as you get better and better at it and you get more experience with it, you'll find that you'll start looking at this stuff. It just comes to you. You look at it, and which is what they say, security people in particular, they say once they learn about security, they never look at anything the same way again, right? You don't look at an open door the same way. You don't look at, you just don't. That's good and bad, I don't know. But anyway, you do think of your systems differently. You think about, what could somebody do? What could go wrong here? And let me fix it, and so on. So it becomes a part of who you are. It becomes a part of how you develop. It becomes a part of how you architect. But I think we're better for it. And so I'm okay with that. If this is what it does for people when they start thinking about this stuff, I think it's a good thing. So, yeah, we're not done, but we want to review again if we missed something. And if there's anything new, we want to review again. So it's not just something we do once. and so that was interesting, and then go on. It's something that hopefully you're continuing to revisit, you're continuing to update. So now finally, you have the 4 things in place for your threat model, and ideally you have what I call a living threat model. Essentially, it's not just something that you did once since exercise and I'm done, it was great, but it's something that you continue to update. So your challenge is really to use that threat modeling for security design before new features, driving your testing. So you'll find that, especially for those who are doing any kind of testing, threat modeling can help you think about where are the places that I'm probably most vulnerable so that I can test with security in those places, in those areas. And then it also helps you understand the bigger picture. I found that when I worked with teams and we did a threat model, that maybe I have a UI person who has no idea what was going on in the database exactly. Or I have a middleware person who has no idea on the other ends, no clue, doesn't care. But now we've got a team that understands kind of how things fit together and the security of that system as the data goes through. And so now they understand a little bit more about the bigger picture. So some resources, and we're wrapping up here. I want to also give some time for some questions, but some resources I wanted to point out. Oh yeah, absolutely. Some books there available. All these slides are going to be available, by the way. I'll give you a link here at the end. So some really simple tools to get started. You can use a whiteboard. You can use Visio, Word. You can use this thing. Dennis Cruz has this great page, and I've used this when I've done workshops where I print this out, this page that gives you a way to record your threats. It has on one side and on the back, it has all the things about Stride. It has all the things about data flow diagrams. And it's just a great way in a one-page threat model tool to be able to record some things and think about a system or a part of a system. You can also do this. I've done this as well just to keep track of things, a worksheet to keep track of your threats and mitigations and so on. You can do this, of course, with Jira, many different ways to track these things. And then there's some other tools out there available. The threat modeling tool is one that's pretty popular. It's from Microsoft. It's free. And what it does is it uses a data flow diagram. It uses Stride. And it allows you to create the diagram in a canvas and then analyze the system for threats based on Stride. And so it's a pretty nice tool. And then there are a few other tools, Threat Modeler, that helps you do some of that same thing. Iris Risk does some similar things. There's another tool that I've used, just came out last year, a pretty cool tool called Threat Dragon. And it's a web-based tool, and it's from OWASP. I know the guys who are working on that. And it's very similar to the Microsoft threat modeling tool. The difference is that the Microsoft tool is, guess what, Microsoft. It only runs on Windows. Whereas the OWASP Threat Dragon, it's a new project. It's still in working on a beta for that. It's an alpha at the moment. But they're working on a beta, but it works on Windows, on Mac, on Linux, or whatever, because it's web-based, or they also have Electron install that allows you to run it on Windows or Mac or Linux, so it's pretty cool. And then some other resources there. One last thing I want to leave you for resources. Great channel if you're interested in the OWASP threat model Slack channel. This particular one, I'm on there. Several others that are in the threat modeling realm, if you will, are on there. And we talk about threat modeling. We're trying to improve it. We're trying to think about tools. Each year, at least certainly this past year and next year again, last year and this year, I'm in the new year. There's an OWASP summit that happens in Europe, and one of the tracks that I was on this past year, and they're going to do again this year, is the threat modeling track. And again, it's just trying to think about this stuff, trying to improve it, trying to get information out there. So some pretty cool stuff. Any questions today? Let me ask that, and before we go, yes. So your service, so if I understand the question, you've got one service, but it connects to 40 other different services? Yes. Sure, sure. What I've done with teams that have a lot of microservices is I try to figure out if there is some kind of connection between several that are similar. So let's say there's 5 services that are doing reporting, as an example. So I'll focus on those 5, but maybe those 5 still connect to 100 other things, or they come into it. And so I'll just kind of block those off and say they're out of scope. We know they're there. We'll get to them. So I do that first one. And then I'll do the next cluster. And I say, okay, there's reporting. We already did that one, so that's out of scope. And so I'll do another 5 or 10, another 5 or 10, another 5 or 10. So I try to break it down. And what I find is that, what is it, the pizza, that analogy? Like I just have enough to do, for a pizza, that kind of a team, and only a few things that I'm working on. I try to figure out where those divisions are and do a threat model there, and then see how it connects to something else and how it connects to something else. If I try to threat model the entire thing, I'll never get there. So I try to break it down. And so what that does is, especially if you have a couple of people, let's say a security person who's kind of following this, eventually what you're going to find is you're going to see where the connections are between them. And then ultimately all you need to do is threat model those particular connections. And then you're done, if that makes sense. So it's just, how do you eat an elephant? One bite at a time type of thing. You just kind of work your way through. That's how I've approached it. And it seems to have worked pretty well with some of the teams I've worked with. Good question. Any others? Oh, yes. Yes. Okay. Yep. Mm-hmm. No, to me, threat modeling, if the question is in terms of the RASP and basically just let developers do the work. Just don't impede them. Let them do the work and put the stuff in, the libraries and so forth, that will do the testing for you and things like that. Where does threat modeling fit in all that? Is that essentially what you're asking? To me, again, you have to have some kind of design there. And so when I've done this, workshops and so forth, I still want to teach people how to do threat modeling, whether they do a formal process or not. And so in that kind of a situation, I would say, first of all, they had to have some kind of design. So there's some threat modeling going on there regardless. But if you teach your developers how to threat model and how to build good security in, they're already doing threat modeling. So rather than say it's a separate thing that I do, which sometimes works, in that case, DevOps and so on, make it a part of the process that they are trained to do this kind of thing, and then it becomes a part of the system, if that makes sense. No. No. Think about it, and then on top of that, help them to understand, to identify things that do need the security person in place. Maybe they have a question about something. Maybe there's a new way, a new framework we need to put in place. Maybe there's a new library. Can we get a review on this and determine what are the implications if I use this particular framework or not? Then you definitely want the security person involved, if that makes sense. That's my approach. Okay, yes? Mm-hmm. Right. That's a good point. So the point was that security is more like debugging than building. And that's true, that in terms of, especially when I have worked with developers and we say, okay, there is a security issue and you need to fix it. And sometimes their reply is, well, nobody ever do that. I only think about what works correctly. You know, a developer's always thinking about what works correctly. Now, they may have some negative cases in there, but they're not always thinking about the ways that their system can be subverted. But to do that, you do have to work your way backward and break it apart and think about, you know, all the moving parts and what affects something else and how could that potentially be a vector into the system to break it. So good point. And it is a mindfulness. It is a mindset you have to teach. To me, threat modeling is a mindset that you have to teach. It's not something that you just go do it and you're done. It's something that you continue to do, you continue to grow, you continue to build and encourage. Any other questions? Yes? I have. One way I've done this with workshops, and I have some out on my website, I have some presentations, I think, that show something about the workshops. But what I've done with workshops is I will give a data flow diagram, and then I'll say, okay, you know, figure out. Well, first of all, the first step is draw a data flow diagram. So I give them specs, and then they draw it, and then I say, okay, here's a data flow diagram. Now let's try to figure out some things in it. And so much like at the beginning where we talked about some systems in various places, I ask about, you know, can you tell me about this? By asking those kinds of questions and going over, you know, simple things and move from there, it's helping to kind of train and build in those skills. So that's my approach, and it seems to have worked pretty well. Yes? Right. All of it. The threat model itself is my understanding of the system, the architecture of the system. Yes, absolutely. To me. Now, some people I know skip step one because they're not visual people, and so they like to think in lists. So they think about the threats, and they think about the controls, and they think about the risk and so forth. So they may skip one altogether. And that's okay. You know, everybody thinks differently. But for me, and most people in threat modeling, they'll say it's really those 4 steps. It's some kind of diagram, some kind of representation of my system so I understand it better. And it helps me to think about the rest of it too, because if I don't know A connects to B and how do I know there's a threat there, right? So, but all of it together is the threat model. Yeah. Exactly. It's a way of getting there to help you think about it so that I know that A connects to B and what is it connecting, how is it connecting, what kind of data is flowing across, what kind of boundary does it cross. Then I can determine the rest of it, which are the threats and the mitigations that are missing and so on, if that makes sense. But yeah, some people will just say, here's my threat model, and they give you a data flow diagram. That's not it. That's just the start of it. So yes, good point. Okay. Any other questions? Great questions. All right. All right, well, this is a survey that I think apparently, from what I understand, is available a few minutes after the presentation on a mobile app. I do not have this one, but that's what I understand. It's out there. So I appreciate some feedback on that. And then finally, here's the presentation. So if you're interested, I've got, you know, obviously quite a few links and so on out here on the presentation. This is available on my website as a PDF file, so if you put that code in, and you know, this is the only place I'm going to show it. So if you want it, get a picture of it. But that code will take you to the slides that you're welcome to look at. Otherwise, if you go to my website under presentations, I got a lot of other presentations where I've done something similar this talk. So you're welcome to that as well. But this one in particular for CodeMash is right there at that URL. Okay. Any other last thoughts, questions? Hopefully this was helpful. Hopefully this is something you'll continue to take back and you know, put in place if you haven't already, or continue to do so in your own teams and organizations. And I'll be around today. I need to head out tomorrow, but I'll be around today if you have any questions. You know, feel free. All right. Thank you.